So yeah, my name is Felix Geisendörfer, and today I'm going to talk about programming flying robots with Node.js. But I'm not actually really a robotics guy. Like Elia, he's a really robotics guy. He's building his own robots, he's putting them together, he's writing a lot of good code for it, and it's like so much more work. I'm more like a spare time robotics guy, so I just buy something that already works and then I program it, and it's a lot of fun. But so the whole point of this talk is to get people excited about it. When I'm not doing the robotic stuff, I run a company called Transloadit. We do file uploads, video encoding, and shitty Wi-Fi. If it's not working for you, sorry. And so we are using Node for that as well. So I came to Node through that project. So why am I doing this? When I have like an actual job to work on? Well, flying robots and Node.js, right? I mean, why would I not do this? It's really fun, but hopefully later we can also find some things that are actual justifications for spending more time with it than just having fun. All right, so this is a paired AR drone. I have one right here. It's basically sold as a toy. You can buy it, it's like 300 euros, and it's controlled from an iPhone or Android phone. So I guess everybody wants to see that thing flying, so let's start by flying it for a second. So the drone itself has its own Wi-Fi network. So I basically just have to log into the Wi-Fi, which I'm doing right now. By the way, nobody else please log into that Wi-Fi. Don't fly my drone away, that'd be cool. And now I just hit a button to start it. And basically, it's hard, nobody's going to see it, but you get a camera image on the phone from the front-facing camera, and you can control it, so it can take off. By the way, I didn't ask the people. Oh, go ahead. Yeah, I was going to say, you can buy this thing and fly it. It's like not impressive, but thank you anyway. Yeah, so it's a toy, but to me it's much more than a toy that you can fly around because it's full of like really good stuff. It's a good platform for doing other things with it. So it has a 720p front-facing camera, which does 30 frames per second. It has a 240p vertical camera. The image is really shit, but it uses it internally to look at the ground and judge ground velocity so it doesn't drift away. It generally works well. Sometimes it doesn't. It has a 1 gigahertz 32-bit ARM Cortex-A8 processor, which is kind of overblown for this platform. I don't know what it needs a gigahertz for, but they put it in there. It has 125 megs of memory. It runs Linux 2.6. You can actually telnet into this thing. Let's do this for a second. So I can. I need the network. Where's my network? Printer? No printer. Sorry. I guess I'm already in the network. So yeah, you can literally be like telnetting into this thing, and yeah, now I'm telnetted into a flying robot, which is pretty cool. What else is there? So it has a lot of sensors in it to basically be able to fly and not fly like crazy. It has 3-axis gyroscopes, or 3 gyroscopes for different axes. It has 3 accelerometers, 3 magnetometers. Those are all used to basically just know if I'm drifting or if it's stable in the air. It uses it for that. It has a pressure sensor and an ultrasound sensor. Both of those are used to judge the height on the ground, so it knows how high it's flying. So it can keep a certain altitude that you want it to fly at. And what's also really cool, it's fully repairable, because this thing will break, to be honest. If you fly it a lot, you'll break one of the rotors, or maybe a motor will go bad on you. No! Oh my god, they're coming for us. So robots are taking over. I was not expecting it to happen as fast, but here we are. It was nice to meet you guys. Also for the people in the first row, when I do some stuff later on, I don't know if we have insurance here, so just cover your face or whatever. But I was going to say that they can break, but you can repair them. You can get all the parts. They're pretty affordable, and you can just replace them. I broke a rotor while I was here and just put another one on. So that makes it actually useful for more than like a few weeks of fun. You can buy it and then keep it and maintain it. So another thing that's really cool about it is that Parrot, the manufacturer, they kind of want people to make mobile game apps. So they want people to buy multiple of these drones and then like fight in the air and shoot virtual missiles. So they have these augmented reality games that they want people to create. So in order for that to work and other companies to be able to make it, they had to open the protocol. So basically the communication my iPhone is using to talk to this thing is documented. So the documentation is shitty, but with a little reverse engineering and trying to make sense of it, it's pretty doable to implement. And that's very nice. And this actually turns it from a toy into a robotics platform that you can have fun with. And the firmware itself, unfortunately, is not open. So if you want to run programs on the drone, on that 1 gigahertz thing, you will have to do a lot more work. It's much harder. Some people have started that. There's one project on GitHub for an open firmware. So some people have just written their own firmware for it. And the manufacturer doesn't try to make it hard. Like you can telnet into the thing, upload binaries and stuff. But it's still a lot of work to figure out how to talk to the hardware. But this stuff is coming along. All right, so that was a little talking about it. Now we could try to program this thing and actually make it do something by programming it. Before I get started, let me move it a little bit. All right, so network programming, live. Let's see if that works. My shell is hanging, not good. So let's create a file here. Let's call it fly.js. And so I don't know how the font size is doing. This room is very big. Let's see if somebody can see that. People in the back, is that still okay or bigger? Bigger? Bigger. Okay. Is that okay? Okay, cool. We'll try that. So the drones themselves, when you want to talk to them, there's multiple communication channels. But the ones for doing a takeoff, that's called the control channel itself, and it's working via UDP. So who has done work with UDP before? Like UDP stuff? Okay, so you guys should know, but for those who haven't, UDP, unlike TCP, doesn't have any error handling. So you send off a message, a packet, and it may reach the target, it may not. But there's no guarantee for delivery. Another problem with UDP is you send a message, and that message may arrive after another message that you send later on, so the ordering is also not guaranteed. What's really good about UDP, though, is the latency is good, because you don't need to do a round trip to acknowledge stuff being sent around. The error handling is not there, so you can have smoother control. So the drone uses UDP, and we need to talk to it using UDP. So in order to make up for the problems with UDP, we include a sequence number in each packet, and we also keep sending the packets every 30 milliseconds. So let's do this. Sequence number is 0 initially, so we're setting an interval every 30 milliseconds. And now we need to create a comment string, which we're going to call comments. And in the string, we're going to add the comments we need. So this one's called atref. Ref stands for, I don't know. And it's very cryptic, so they don't tell you these things. But basically what it's used for, it's for takeoff and landing. So you send this comment for it. So we include our sequence number, we increment our sequence number, and that's our first argument. And the second argument is the ref argument itself. Let's see. Okay. And oops, oh, I'm not good today. Too much drinking. So and each comment is delimited with a carriage return. And then what else am I missing? I need the actual parameter. And so the parameter is, we're going to do some bit shifting magic now. I'm going to explain it in a second. So there's two arguments that are going in here, which we're going to need to define. Flying equals true, I guess, initially. Emergency equals false. So we have those two. And so basically evaluating this expression, shifting flying, the Boolean operator, 9 bits to the left, should result in, I guess, 512, and the other one should be 256, and then the two get added together. That's really just producing a number. But they decided to make a text-based protocol, which is nice, and then they decided to add binary stuff into it, which is not so nice. You kind of get the worst out of both worlds. I don't know, whatever. So the second one is really more for you guys than for me, because if I was going to execute the program without the second comment, the people in the first row would really get screwed. Because the manufacturer decided if you're not telling the drone to stay still, it can do whatever it wants. And it will do whatever it wants. It will kill people, or at least try to. It's not powerful enough, but it really wants to kill people. I don't know why it does. And so for you guys, I'm going to include the comment to not kill people. This one is called PCMD. And it also gets a sequence number, and then a bunch of parameters, which is 5 zeros. Those would be used if we're going to fly around. But then again, they decided instead of just making these numbers, like the actual numbers, you have to convert them into floating point representation, and it's stupid. So we can't do that without more work. But for takeoff, it's good enough. Just stay still. All right. Then what we need to do with the comments, and we are lacking something. We lack the carriage return here. So now for Node to be able to send this off, we need to create a buffer. So we're going to put our comments in a buffer. And holy crap, I just did something I didn't want to do. OK, here we are. So we create a buffer out of the comments. And then we say, we need a UDP socket. So let's create a socket. Well, I guess that's not a require. That's a decram create socket UDP4, IP4, and this socket we can send this stuff to. So we're going to say socket send, and I think it's buffer. Then we tell it we want to begin at the beginning of the buffer, byte 0, buffer.length to the end. By the way, this API could be made nicer. It's annoying. And I guess I should do that. But it's open source. What? No, oh God. I'm really worried this is not going to work because... What? Yes. Oh God. God. I'm really sorry if I kill somebody, or I don't want it. So, okay, what's next? I think it's... no, the port is 5556, and then it's the IP address, I think, 192.196.1.1. OK, I think this could work. Before I'm going to execute it, I'm going to do just a little test to look what this actually looks like. I need to call JSON stringify here, because otherwise the carriage return is going to do stupid things in my shell. So let's do this. And let's deactivate this for a second. And let's, what? So, okay, so this is what we would be sending to the drone. So 512. Why is it 512? Oh, because emergency is false. And PCMD to basically tell to not kill people. All right, I'm nervous. I don't know if this will work. No, I don't know. I'm nervous about operating heavy machinery under the influence of alcohol left over from last night. That's what I'm mostly worried about. So anyway, we're in the network. I just checked this. So we should be able to send these comments. There's right now no code to land it. So I don't know. I don't know what we'll do about this. Let's try it. Yay! Cool. That worked. That is a kill switch, by the way. If you're being attacked by a drone, so this is this is how to defend yourself. Okay. I guess. So nobody wants to do this by hand, like implement a protocol. It's nice for like demonstrations that you can do it, but in order to have more fun with this, it's not very practical. So I've written a client library for this on GitHub. It's called ARTrone. And with that client library, we can do nicer things. So we can say client equals ARTrone dot create client. Oh God. So, and then with the client, I don't know, it has a REPL. So let's create REPL. Wow. Okay, so with the client REPL, we can actually have an interactive environment, and then we can try something. I will try something that possibly will break this thing, and there's not enough space to really try it, but I want to do it. So let's see if it works. Okay, so first of all, we can do a takeoff. Oh, we can't. I guess we're not. Oh, it's in emergency mode right now, and emergency mode means that it's not going to take off. And I've not, because I didn't really think this through, I have not implemented the getting out of emergency mode code. I guess we can take our other example here to fly code and set emergency to true and fly to false. And that should turn our lamps to, right now they're red, so that means it's in emergency mode, but running this should turn them green. Yep, so now they're green. Now we can fly, and the client should work. So, okay, let's try the takeoff. Okay, and now I can try flying up. And now I'm going to try something that will possibly break it. Oh God. Oh God. God. That was not supposed to happen. Well, I guess we'll let this thing fly for a second. Maybe it will crash into something by itself. Oh, it is. Bad Trone and bad programmer. I have not really done this well. So we need to fix this. I actually don't know. Why is it doing it? Because I added this thing that I shouldn't have added. I was working on this library right until I get up for this, and that's not a good idea. I guess this UDP nav data stream is not what we need. Let's disable that. And now let's try it one more time. Take off. Oh, emergency again. Okay, let's get out of emergency. Good. Ah, somebody's paying attention. Take off. No, don't. Let me try to navigate it. Oh, wow, that was much faster than I wanted it to be. Okay, I'm going to move it by hand. This is not going to work well. This REPL is nice, but it's not very practical to control it. All right, now let's try the thing that's probably going to break it. No flipping today? No, it shouldn't be an emergency, no. Oh, it's a battery. It could, yes, if the battery is too low, it will not do a flip. That's shit. I used up too much battery playing around with it. Well, I guess I promised it to crash, right? So we'll just crash it because the battery is empty. What should we crash it into? I guess Nuno, he's defended. Let's try to crash it into him. Woo. So I guess at this point most people like this thing and they need an excuse to get one. So if you need excuses and you maybe want your company to buy you one, here's a list of excuses to rationalize the purchase. first of all, when you program these things, you actually program a production system all the time. And like debugging the production system is very hard because once it's flying and you're like on your little terminal, you're like get very nervous and it crashes. And your place is going to be like smaller than this, and you're going to crash things all the time. So what you learn is like how to write code for production systems. You really get to appreciate writing some tests. You really get to appreciate good logging, so you can analyze things afterwards. So that's pretty cool. You also get a chance to look into fields that you're normally not touching so much, like artificial intelligence and image recognition. You can actually get the camera stream with my library and use the OpenCV library to detect faces and all kinds of cool things. And you get to learn about like robotics tools like PID controllers, which are proportional integral derivative controllers, and they basically make smooth movement happen. So if you have a point where you want to fly to, and you know your current point, the difference is the error, and so the PID thing takes a proportion of that error to apply an output, in this case like maneuvering, and the IND, the integral, will add up, for example, the error over time if the output is not enough. And it's like the super smart stuff that the robotics people are using, which was actually invented in the 20s by some Russian guy for the US Navy. But this stuff is actually useful for web development because, for example, if you have to scale computers up and down, you generally don't know that X amount of work needs X amount of machines. You just know if there's more work, I need more machines. And so these controllers can actually be implemented in loops like that will smartly control your production systems. So it's really cool to play with these robotics things and learn some stuff. Yeah, I guess this is the library. And it's unfortunately sold out, but we're doing an event on October 5th in Berlin called Nodecopter. And we basically get 20 teams with 3 people each, so 60 people, to program these things all day. We have like an old swimming hall with 13-meter high ceilings, and we're just going to hack with this stuff all day. It's going to be fun. If you're in Berlin, maybe we can arrange that you can hang out or something. Just let me know. All right, what else is there? Thank you. I guess that was it.